Yeah, so let's get started. I think I have a few minutes to show you a quick introduction to SYCL. My name is Thomas. You can just contact me on Slack or whatever if you have any question. We'll go quickly an overview, how to compile, and a quick conclusion. So Colin show you this slide, and maybe you never heard about SYCL. So is this thing really used? So first you see here 23 project is using SYCL. So more than OpenMP, one more. Thanks for the guy who make the balance in my favor. And then you see you have other programming models that we'll discuss later, like Oka, Cocos. And maybe something to know is like Cocos and Oka are also using SYCL, right? They are not directly talking to the low-level backend that we have, which is called level 0. They are talking using SYCL. So SYCL is kind of a foundation layer, let's say, if you want to build more complex stuff, or you can use it also in your application directly. So here, a small code example. First thing to see, no pragma. So you should be happy. Second thing to see, no weird chevron like C++, like CUDA, for example. So it's pure C++. So how you do is like you create a queue with like a stream, more or less, in CUDA. Then you can malloc the memory. Like for example, in CUDA you do CUDA malloc device. Here you do malloc device. It is templated with the in, so you can get some stuff. You get a row pointer. And then it is a pointer that you can use on your device, and you use your stream to submit a kernel. And it is a lambda, or you can pass a struct if you overload the parentheses, the functor. So you can do that, then you can use your row pointer that you allocate to your memory. Everything is asynchronous, so you need to wait. And then you can do the same, for example, if you want to do a copy to bring back the memory from the GPU to the CPU, you do a mem copy, a host to the device, an exit data, a map from, whatever you want to call it, and then you're free. So it should look pretty straightforward and unimpressive. All the concepts are pretty basic, and I think this is what I like in SYCL. It's like it's not too fancy, it's just purely kind of a mapping, a nice C++ wrapper around low-level stuff. We have far more example here. I put the slide on the Slack, so here you have far more advanced in your SYCL training or nice SYCL of hell if you want to get more involved. So of course, these APIs, these things, I show you more API, I show you a lot of device cores. They are just the tip of the iceberg, a lot of things. You can have access, of course, to mass functions in cos, square root, reciprocal, all these kind of things. You have a lot of intrinsic that maybe is lacking a little bit in OpenMP. Is like, for example, shuffle, pop count, swizzle, when you want to do this warp optimization, this subgroup optimization, you can have them. Then we have API for them. Of course, we have more things. You have MCAD, one MCAD if you want to do stuff, and you have a lot of other API. You have parallel STL and all of this kind of thing if you want to use. And also you have port tools. It's called Cyclomatic if you want to port from CUDA to SYCL. You have a lot of tools to ease you. So if you come to this hackathon with still a lot of CUDA legacy, let's say, you can migrate to SYCL kind of easily. Abhishek is an expert on this topic. How to compile and run exactly like in OpenMP. You just put fsql and you do the JIT and you do fsql target, and I forgot the fsql, and also thing SPIR-V gen if you want to do this kind of directly creating the gen ISA, who is like the lower level and not the SPIR-V with the intermediate representation. One note on how to run. I think this is the easiest. It's like inside, as I say, it's a queue, so it's a stream. So a stream can target a particular devices. So what you do is like you don't care, you just create a stream. It will just take a random device, but the trick is like you use this script and it will play with the Z affinity mask or the CUDA device visible. And each MPI rank will see only one tile. So if you do that this way, MPI rank is just a compact is good. You take a stream, a random stream. I mean, you create a string on a random device, but you see only one device, so everything is fine and you are good. So recommend this way. You can do extra fancy if you want, if you don't like this kind of people setting the affinity from outside. You can take your MPI works, all the device, and then you round robin between your word rank, and then you create a context, but it's far more involved. You need to understand affinity, visibility, flat, sub-device, and all the defect of context. So you can do that. It's just a little bit more challenging. So in conclusion, for my 5 minutes, I think it's good as a mental model to imagine SYCL just as a portable wrapper on C, C++. Sorry, a portable wrapper over the lower level API and C flavor language of kernel. So, and it is portable. You can use SYCL on CUDA, on Polaris with with a CUDA backend, or you can run with an OpenCL backend on your laptop, or you can run with Level 0 on Aurora. So it's run everywhere. We have also a heap backend. I saw you he see raw pointer and stuff like that, but we can have far more fancy C++ thingy with fancy allocator if you want to use a vector shared MD spam if you don't like raw pointer and a lot of things, just ping me in the repo. We have example on this one, the one I linked before, nice SYCL of hell. Just compile FSYCL, we plug all the header and everything. You can talk to Happy and me if you have any kind of question, bugs or stuff like that. And if you find bugs or if you think SYCL is missing stuff, we are pretty eager of getting feedback. Here I talk more as a SYCL committee member and less as an Argon person. You can just talk, open an issue. All the specification work is done in public. So please open an issue and I will try to reply to you and stuff like this. I think we got a lot of feedback from our CUDA user or Cocos for stuff we were missing in SYCL and we are put it back into the specification. Thank you very much.